Second question regarding the governor valve using EH oil or phosphate oil and have a water content 5000 ppm. So this customer already know that the root cause is regarding the cooler system leak, cooler system leak. Sorry, and please inform what other problem will be facing if the water content are high in a phosphate ester and Baik, selamat siang Bapak dan Ibu. Kami ucapkan terima kasih karena telah menghadiri webinar pada siang hari ini. Sebelumnya kami informasikan juga ini merupakan seri webinar yang kelima di tahun 2021 yang kami awali di bulan Januari, dan kami ucapkan terima kasih sekali lagi. Pada dasarnya kami juga mengharapkan untuk kedepan-depannya bisa mengikuti webinar series dari PT Tiara, yang mana kami secara konsisten untuk melakukan sharing knowledge terkait dengan reliability aset di tempat Bapak. Nah, pada webinar hari ini saya akan didampingi dan sekaligus sebagai pembicara. Pembicara pada siang hari ini merupakan Bapak atau Mr. Lars van Dijk. Terus kemudian untuk sebelumnya untuk Pak Lars ini saya akan bacakan terkait dengan deskripsinya beliau. Lars sendiri merupakan saat ini home base-nya itu berada di Singapura pada tahun 2013 dan aslinya atau asalnya itu berasal dari Belanda. Kemudian Lars pengalaman pada industri otomotif dan lubricant additive industry, yang awal karirnya sebagai marketing manager di Bosch Workshop Concept di Belgia. Sebelum join di BRB Internasional sebagai sales manager untuk lubricant additive. Nah, BRB sendiri merupakan anak perusahaan dari Petronas Chemical Berhad, dan Lars bekerja di divisi lubricant additive selama kurang lebih 10 tahun sebagai sebagian besar waktunya berdedikasi untuk meningkatkan bisnis di area Asia Pasifik dengan home base-nya di Singapura. Selama berkarir, Lars banyak berpengalaman di lubricant chemistry, tribologi, dan international business. Dan pengalaman ini diaplikasikan di perusahaan Fluidtech Singapura sebagai General Manager di Asia Pasifik. Kemudian hari ini Lars akan sharing pengalaman terkait dengan lubricant fundamental, monitoring, dan maintain turbine oil pada khususnya. Diharapkan dengan sharing webinar ini, tujuannya adalah untuk sharing bagaimana menjaga agar oil tetap bersih, pure dan free dari varnish yang sangat berpengaruh terhadap umur oli, dan salah satu juga untuk menjaga reliability dari aset. Selain itu, dengan harapan extend lifetime dari oil itu sendiri, penghematan bisa dilakukan dari sisi maintenance budget dan environment. Tidak lama-lama saya introduction pada siang hari ini. Dan kemudian kurang lebih webinar ini akan waktunya kurang lebih 1,5 jam. Dan jika ada pertanyaan atau kira-kira yang kurang jelas, bisa dituliskan di kolom chat di bagian bawah untuk Zoom-nya. Untuk nantinya akan kita informasikan ke pemateri dalam hal ini Lars. Oke, saya kira cukup untuk introduction di siang hari ini. Silahkan. Hi Lars.
Hello, Adi.
Hello,
thank
Lars.
you very much.
Thank you for joining us on this webinar. Hope you all well. So I have already a short description of you, and please you can start this webinar or sharing knowledge.
Okay, thank you very much, Adi, for that introduction. A big thank you also to PT Tiara for allowing us to present to you our knowledge today and share with you some of our knowledge. We hope it's very useful to you. And please don't be shy to ask any questions you have. If we don't have enough time to address it today, we will make sure to follow up and then come back to you at a later stage. So then let's get started. I'm going to open my PowerPoint. Adi, please, can you let me know if you can see it okay? Okay, so I assume all is good. So welcome to our webinar. The company that I'm representing today is called Fluidtech. So I'll give you a little bit of a brief introduction to our company today. Then we will talk about the lubricant fundamentals related to turbine oils. After that, we will go into how you can select the proper turbine oil for your application. We will show you a little bit about our experience with oil degradation, what we see in the field, oils degrading, and what kind of problems that you may encounter. We will share our knowledge on monitoring the condition of turbine oils, how you can prevent breakdowns, and we will present to you finally our solutions to varnish. It's quite a lot of content, quite a lot of topics to put into 1.5 hours. So I need to keep the speed, so I will probably be a little bit quick. But as I said earlier, if you have any questions, please don't be shy to chat with us, and we will follow up when we can. So to introduce Fluidtech, we are on a mission, I should say, to achieve Fill for Life. Now, Fill for Life is a big goal. It's difficult to reach, but that's why we are in business. So we want to extend the fluid's lifetime in the equipment to a point where you don't have to change it anymore. We are not there yet at the moment, but we are getting close. And by doing this, we have actually been approved by major gas turbine OEMs. We have saved more than 1.5 million gallons of oil from being wasted prematurely. 9 out of 10 global oil companies actually use or recommend Fluidtech solutions. We are doing business in over 100 countries on six continents. And probably the most important is here in the middle, we have managed to reduce more than 100,000 tons of CO2, which is documented. In reality, it's probably more. And by using our solutions, our customers, the end users, have documented more than $100 million of savings. And we've also managed to save a lot of days of outages by our customers, the end users. For example, in the power generation industry, it can save a lot of value if you don't have to do a lengthy shutdown by preventive maintenance. So Fluidtech has offices around the world strategically positioned to serve key markets. Our Asian headquarters is based in Singapore, which is where I'm based. And we have a joint venture with some production facility as well in Melbourne. Our corporate headquarters is in the Netherlands, in Dordrecht, and our R&D facility and main production facility is in New Jersey in the USA. So for us, it all revolves around understanding and solving varnish. So varnish is just one word that we use for a lot of different things. More common words that are known are sludge deposit, coking, carbonization, a lot of different things that are actually under the umbrella of varnish. You can see here on the pictures that there's many different forms and kinds. Can be different in color, can be different in chemical composition, can be different in the type of harm that it does. So it actually is prevalent in a lot of different industries around the world. And that you can see here in this wheel, which represents all the industries that we are in globally. So for example, power generation is a big industry for us, but basically all the industries that use rotary equipment that can have varnish issues in their system. So very wide variety of applications. So at Fluidtech, our value proposition is that we want to offer fluids as Fill for Life solutions in lubricants and hydraulic fluids. So we want to change the mindset from using a lubricant as a consumable and changing it very frequently, but using a lubricant as an asset, as something that you can use, you can extend the you can additional value with the lubricant. Because what we have found out is that our customers want reliability of their industrial equipment, and they can achieve that by contaminant-free lubricants and hydraulic fluids, and they want environmentally sustainable solution. Going green is a big topic worldwide right now, and this is what our customers are looking for globally. So to do that, we offer a proven range of reliable technologies which exceeds the requirements of our customers. We are quite unique in the technology of fluid monitoring and maintenance, and sharing our knowledge in this area as well. We use a holistic approach to look at the total situation of the customer. We are globally renowned subject matter experts with deep knowledge in lubricant management, and we have been doing this for more than 20 years, so we have a big database of experience. We achieve our goals by heavily investing in R&D and develop our products together with OEMs. For example, the major turbine OEMs recommend FluidTech solution. And we approach fluid management from a chemical perspective. That can be treating of fluids or filtration, chemical filtration of fluids. We offer re-additization and very premium long-life lubricants, which reduces consumption and reduces the downtime of your assets. So the product line that we have, recently we have added the product line called Education, because we have found that our knowledge is actually an asset that we can share with the industry and our customers through this kind of webinars. So that's called Education. We have Lubrication Academy as our own webinar, and the virtual summit which we held last year will be held this year as well. The other one is condition monitoring, to monitor the conditions of lubricant. We have invented Ruler and MPC, which are according to ASTM standard and recommended by major OEMs. Contamination control are unique products to filter out oil degradation byproducts and to prevent the formation of varnish in your system. And Solvencer is either deposit control, contamination control, or the replenishment of depleted additives such as antioxidants. So we have a wide range of products available. So by doing this, the way that we do it is different from how it is traditionally done. So traditionally there has been low analysis and low frequency. There's a lack of data related to oil analysis on our customers. Aggressive cleaners are being used, and they replace lubricants whenever the additives are depleted, or when the lubricant becomes spent, just gets thrown away and a new lubricant gets into the system. Filtration media basically has not changed in the 1950s and are actually not so efficient for current day standards. There's frequent oil changes and no warranty given by any oil suppliers on degradation. So the FluidTech way is to analyze with our Ruler and MPC. Instead of using cleaners, we have products to flush, for example, our Decon and Boost VR. We can re-additize turbine oil. We can clean the oil in line without having to change the oil. And this all leads to life extension, where instead of throwing the oil away and charging it with new oil, you can actually extend the life of your oil significantly, and thereby saving money. But also by managing your oil as an asset, you reduce breakdowns and downtime. So we do this by measuring. So first of all, it starts with condition monitoring the health of your fluids. Then we consult, we tailor our consultation to the situation of each customer. So it's a very individual approach. And then we treat by providing a solution to the specific problem, or sometimes it's not really a problem, it can also be a preventive measure that we see at the specific customer. So it's a holistic approach, a total solution approach, I would say, for customers' assets. The reason why customers trust us is because we have unique and superior products. There is no other company at the moment like FluidTech that can offer this wide and holistic view on things. Sure, there are specific competitors in certain areas, but we have a unique view from our specific experience in lubricants. So that's how we can tailor our solutions to each customer. We prioritize science. Of course, we are a commercial company, but we develop our solutions on a scientific basis and with science in mind. We have 25 years of proven track record and industry-specific experience, we are recommended major OEMs and major oil companies. And by doing what we do, we add value. We increase the customer's efficiency and the reliability of their production facilities. And by doing so, we actually create a very unique return on investment on our solution. In many cases, it's not difficult to calculate how much our solutions will save the customer in money and also efficiency. Our unique approach ensures a risk-free solution. By using our experience and by tailoring our solutions to the customer, it is risk-free to use. So our legacy is that we want to achieve zero industrial waste. This is something that major economies are now looking into, a circular economy. Instead of consuming things and throwing it out, we want to reuse and extend the life cycle of industrial fuels and contribute to the zero industrial waste and circular economy environment. So that covers the introduction. I would like to talk a little bit about the lubricant fundamentals, because it's important to know what a lubricant is supposed to do before we can explain how we can treat it or how we can monitor it. So it all starts with the base oil. Now, in the base oil industry, there's a lot of different terminology, a lot of different words that are floating around, and it can be like a scattered jigsaw puzzle. It's very difficult to make heads or tails off of it. It's very difficult to understand. So that's why it's often very confusing to people who are not from the industry. So today I hope to make a little bit more sense out of this. So a base oil, or a base stock as it's called, is a lubricant component that is produced by a single manufacturer to the same specification. So it's a crude oil that's being refined. It's a crude oil as a feed source, and that is being refined according to a certain manufacturer specification. So if you look at the second part here, you will see that there is many different manufacturing processes, such as distillation, solvent refining, hydrogen processing, agglomerization, and so on and so on. So with all these different processes, you get a lot of different base oils that are different in composition and therefore will perform different in the application. So that's why there's a lot of different base stocks going around. So the base oil is very important because it is the platform on which the additives ride. So the base oil is preventing the major functions of the lubricant. It provides a lubrication film, it provides the minimum viscosity, and it needs to be strong, stable, and inert. It needs to be non-damaging to your equipment, and it needs to be kept clean and pure. So very important about base oil is the lubricant cannot perform without a clean and pure base oil. So in order to perform, a lubricant needs to have a clean and pure base oil. And this is very important, and I want you to remember this today. If there's anything you take away from our presentation, then please let it be at least that you remember after today the base oil in our lubricants needs to be clean and pure for the lubricant to perform. And this is the basis of everything that FluidTech does. All our solutions are tailored around keeping the base oil clean and pure, so it can provide its major function as the backbone of every lubricant. Now, if you look at a typical turbine oil composition, you will realize why the base oil is so important, because it consists of 99% of a lubricant. So 99% is the base oil. So most of the performance of a turbine oil comes from its base oil. The rest of it is mainly antioxidants, rust inhibitors, and foam inhibitors. Relatively simple composition, but it has a very important job because it goes into high-valued assets such as big turbines in power generation units, for example. So a little bit about the different base oil groups. So there has been an evolution in the lubricant market, or maybe even some would call it a revolution, because most of the formulations over the past 10, 15 years have gone from a group 1, which is crude oil that has been subjected to solvent processing, solvent subtraction. So that's the way it is refined, and this leaves some unsaturated and polar components in the base oil, and you can see this from the color as well. It is a bit lower in purity than a group 2. So we moved from this base oil, from the group 1 to a group 2 over the last 10 to 15 years. Now, a group 2 is a base oil that is refined by process conversion of molecules. This removes the unsaturated and polar components, so it has a higher purity. With this higher purity, it increases the oxidation stability because it reacts better with antioxidants, so it will be better suited for applications that require a good oxidation stability, like a turbine oil, for example. It has very low aromatics. Now, there's a little bit of a downside to this because you can see it here. A group 2 may have some solvency challenges versus a group 1. Now, this becomes an issue when you think about varnish, because when varnish starts forming in your oil, previously a group 1 could keep it in solution and it was harmless, but a group 2 might not be able to keep it in solution, and it becomes varnish and it attaches itself to the metal, and that's where it can be harmful. So that's why it's important that this change from group 1 to group 2 has significantly increased the varnish problems that we have seen in the market. So now the question might be, so why don't we just use group 1 so we don't have varnish? Well, because the benefits of a group 2 still outweigh the downsides of it. As you can see here, 99% base oil. Don't forget how much base oil there is in a turbine oil. If you combine a group 2 base oil with an additive, with the same additive as a group 1, you will see a significant increase. This is almost 4 times as long lifetime compared to a group 1 with the same amount of additive. So it means basically a longer oil life. And this is why we use a group 2 today, because oxidation stability is more important than solvency. But the downside of it, the price that we pay for this, is that we have more varnish in our system. So we need to put in a little bit more effort and a little bit more investment into managing the oil in our system. Another oil that's being used is a group 4 PEO, which are synthetic molecules, also called designer molecules. They have performance benefits in terms of temperature stability and even better oxidation stability. But they are limited, they are even more limited in terms of solvency. They are the purest base oils in the market. So they lack some of the lubricating properties and some solvency. Also, another challenge with group 4s is with synthetics is that they are challenging to formulate with because of these properties, but also that they are not as widely available as mineral base oil because they need to be produced. They need to be synthesized. The availability is much lower, which of course supply demand leads to a much higher price for synthetic base oil. So that's why you don't see them so much in turbine oils these days. So I want to talk a little bit about the lubricants in general. It's a highly complex system. It's a combination of a careful selection of additives which need to be tested thoroughly with the right base oil, also something that is more difficult to do than it looks on paper, and things need to be properly tested and performance needs to be evaluated. And then you end up with a formulation which hopefully will have the desired performance. So it's always a combination of chemistry and base oils. So the main function of the additives is to prevent oxidation, because oxidation is a degradation of the base oil. And if you remember from our previous slides, it is important to keep the base oil clean and pure. So oxidation occurs when oxygen molecules attack the petroleum fluids, and they literally start to degrade the hydrocarbons, so the molecules of the base oil. And this leads to free radical acid formation, sludge and varnish formation. Eventually the oil will thicken and the lubricant will start to decompose altogether. So this is the main enemy of any turbine oil, because it's accelerated by environments that you will find in a turbine oil, such as temperature. Type of base oil will be important to the way it oxidizes as well. The amount and the type of corrosion inhibitors will be very important to the rate of oxidation of the oil. The presence of oxygen, which is almost everywhere, metal ions and nitrogen oxide. So these are the factors that increase oxidation of an oil. And of course, temperature, oxygen, metal ions, these are all present in turbine oils. So this is an example of an oil, how it behaves when it gets heavily oxidized. You will encounter something which is known as oxidative or oxidative viscosity. So you see the yellow line here, this is a base formulation without any antioxidants. So after around 20 to 25 hours, you will see an exponential increase in viscosity. Now you can imagine if this happens in your turbine, the system will break down, it will be finished. So this is what we want to avoid. And therefore we put an oxidation inhibitor or an antioxidant in the base oil. In this case, only 0.5% of aromatic amine antioxidants is enough to stop this exponential increase. So you'll see that it's much more gradual and you will not suffer a catastrophic base oil, catastrophic breakdown right away. Sorry for that. So if you look at antioxidants, then you say, why don't you just pack the oil with antioxidants? Well, it's always a synergy that you're looking for. So you cannot just pack, for example, arylamine, or arylamine, sorry, or phenolics. You want to have a combination of both because this gives you the best performance. You can see here 0.5% of amines and 0.5% of phenolics give you a better performance than 1% of each of those. So we're looking for the synergistic and enhanced performance. You might also wonder, why don't you just increase the amount of antioxidants in your oil? Well, the answer to that is technical, but also economical, because from a technical standpoint, antioxidants are molecules or components, and they deplete over time. So you have typically one antioxidant and one free radical, and they battle with each other, they cancel each other out. So if you have one free radical that's neutralized, you also lose one antioxidant molecule. When this antioxidant molecule gets inert, it can become something else. It can become sludge or varnish or any other degradation byproduct, or even a free radical over a long period of time. So you also want to limit the amount of antioxidants you put in your system, because it can lead to a problem over a longer period of time. Another factor, of course, is cost. If you increase the amount of antioxidants, antioxidants are expensive, so the formulation cost shoots up immediately, because the antioxidants are by far the most expensive chemical in the turbine oils. So what is expected of a lubricant formulation in general? So one of the major functions is relatively well known, I think, is reduction of friction and wear. The lubricant is there to lubricate, which basically means reducing friction. It reduces heat, it dissipates heat when it circulates, and it gets cooled down by its environment, and it goes back into the metal. It actually cools the system. It also seals out contaminants, which is a function of a lubricant, but a major function when it comes to grease. It prevents rust and corrosion by preventing air or moisture to contact the metal. And it actually has a cleaning function, which is lesser known, but if you think about it, it helps to keep surfaces clean and helps to take away contaminants and settle them in a reservoir. In some applications, a lubricant is actually also a power transfer fluid. You can think of an hydraulic fluid where the piston transfers the power, through the lubricant. And also in an ATF, an automatic transmission, actually part of the power is transferred by the fluid itself. In transformer oils, it can also serve as a dielectric fluid. So I want to talk a little bit about different lubrication regimes for you to understand what lubricants typically do. So you have one of the severe regimes is called boundary lubrication, where you have mixed metal to metal contact, and you have a very thin layer of lubricant and very high pressure, high load on the surfaces and slow speed. So these are environments that are typically found in gear oils, for example. And here you need a lot of surface active chemistry in the contact points to prevent the metal from wearing off. You need a lot of extreme pressure additives and anti-wear and friction modifiers. So it's a very specific formulation. Another very challenging formulation is mixed film lubrication. So you have a combination of metal-to-metal contact, but also a little bit of hydrodynamic lubrication. So this is probably the most challenging formulation because you need to have some surface active chemistry, resistance, and friction modifiers, but you also need to have good hydrodynamic properties of the lubricant. And this is an environment that is typically found in engine oils, for example. That's why engine oils are extremely difficult to formulate because of this. Now, the most common form of lubrication in turbine oils is actually hydrodynamic lubrication, meaning there is more space between the metal surfaces and the lubricant actually fills up the space, and you only have lubricant as a film. There's no metal-to-metal contact present. Typically, this is in applications where you have high relative speeds between the metals. So you can imagine in a turbine or in a bearing, for example, those have hydrodynamic lubrication. So in turbine oils, we look at hydrodynamic lubrication. So this is just to explain to you, if you look at all these different modes of lubricant regimes, as it is called, you have boundary friction, mixed friction, and fluid friction. And they all have a different coefficient of friction and a different relative speed to each other. So that's why you cannot use, for example, a gear oil in an engine oil and the other way around. They won't work. The metal will start to degrade and it will break down the machine. So it's very important to use the right lubricant for the right application. That's basically the main message of this section. So when we look at lubricant functionality, we always have to balance out the properties, because you can go all the way to the side of performance. We can formulate synthetic fluids with packed high-end chemistry inside, and the lubricant will almost not degrade and will not cause any problems. But then it will be way too expensive. It doesn't make sense to use it anymore. And also you will run into availability products, because highly synthetic molecules are limited, are difficult to produce. So you cannot make enough of it to suit the whole world, to supply the whole world. So availability is also a major problem. But in general, it will be a balance between the performance of a lubricant and the cost. So that's why you all are always looking at balancing the formulation in these areas. So I have a question here that I see. So here somebody has a question that I got from Dr. Adi about the viscosity of a gear oil in a gearbox, where the viscosity at 40 degrees dropped from 400 centistokes to 65 centistokes, but viscosity at 100 Celsius is normal. So it always helps a little bit to know what kind of gear oil it is, and to look into the exact application. Usually a viscosity drop like this will be because of the degradation of the viscosity modifier inside. So the viscosity modifier, we haven't talked about this because today is actually focusing on turbine oils, but in gear oils, you typically have molecules inside polymers to maintain the viscosity. And it's possible that these have degraded too fast, and then you will see a drastic drop in viscosity. Maybe it's not the right gear oil for this application, and the chemistry cannot cope with it. That would explain the difference in viscosity between 40 degrees and 100 degrees. In these instances, but we would need to start a little bit of a dialogue on this, and we would need a little bit more information about the exact testing that has been done and the application and the formulation of the oil in order to give a proper advice. But that would be my initial assessment. But there can be a lot of reasons why viscosity suddenly drops. So I would advise to send maybe some information to Dr. Adi, and then we can have a look at it and advise you on this, whether you can still salvage the oil or you should replace it. So the next section is selecting turbine oil. So we talk a little bit about how customers can select the right turbine oil. So formulations are a little bit like politics in a way. You always are measuring and compromising. It's an eternal compromise between different parties and different interests. So you have the OEM, it needs to meet the OEM spec, it needs to have chemistry inside, which is regulatory compliance. You cannot have heavy toxic chemistry inside, for example. It needs to be registered safe to import, because if not, customers cannot use it. It needs to overcome failure modes in the application. It needs to have an attractive product cost, and it needs to ensure supply chain viability. So it needs to be available worldwide. So this is a challenging prospect. So how do you select the right turbine oils? So it's always very tempting, and this is as recent as 1907, this quote here, because it's always very tempting to select a little bit cheaper oil. But if you look at the problems you can run into, and you look at the expenses over the total life cycle of the oil, you can very easily determine that it's never really a good economic deal to use cheap but unsuitable oils, because you will run into much higher cost than just buying a little bit more expensive but more suitable oil from the start. So that's very important to realize. So what turbine oil would you buy? So here you see a typical spec sheet of two similar brands. As you can see, same viscosity, everything looks very RPVOT of brand 2 is a little bit higher of brand 1. So you can say, okay, I would buy brand 2 because the RPVOT is higher. But this is always a little bit tricky, because that's sometimes how oil manufacturers will sell their products. But actually, spec sheets contain basic physical properties, but do not reveal performance characteristics. They may confirm that an oil meets your OEM spec. So if you have on a spec sheet, this oil meets OEM A, B, or C, okay, fair enough. That means that the oil is tested for the application. If this is the spec that is recommended by your OEM, then okay, this oil should be suitable. However, please do not select turbine oils based on the spec sheets alone, and don't look at TOST or RPVOT as the sole indicator for oxidative resistance or lifetime of the oil, because it's much more complex than just these specifications. So you want to be collecting relevant performance data. So what we have done, because of the challenges that we have seen in the market, we have developed a test, an in-house test, to determine which turbine oils demonstrate excellent deposit control and have a very strong resistance to oxidation, because these are the most important characteristics of a turbine oil. So we have run a couple of oils through our TOPP test, which is Turbine Oil Performance Prediction Test. It's a test that is designed by FLUITEC, which is simulating real-world conditions and a good test to evaluate the actual performance of an oil. And what you can see here is already by visually observing the different oils. The test is run for 6 weeks, so you have a baseline and you check after 3 weeks and after 6 weeks. And you can already see here there is some varnish on the test vessel, different in severity and gradient, and also different in color. So already just by visually looking at the test tube, you can already see, for example, it's clear to see that this has a very high MPC value and this has a lower MPC value. Example of a TOPP test. So after 6 weeks of turbine stressing, you see that the pure oil becomes very dark in color. You see the MPC patch turning dark as well. The MPC shoots up, and the catalyst coil that is used to increase oxidation. You can also see color changes on the metal there. So this is an example of a very poor performing fluid. And if you look at what is mentioned on the data sheet, on the spec sheet of this fluid, it will say a unique additive system, best deposit control turbine on the market. So a lot of these things are mentioned, but if you see in the real world environment, they do not always hold value, because you can see the varnish potential of this oil is extremely high, and you do not want this in your system. So if you run all these tests and you collect all this data, how can you then use this to actually come to a decision? So we have tested 9 commercially available turbine oils, 6 weeks oxidation resistance and deposit control. Results are compared, and of course MPC values are measured and RPVOT value compared to new. Ruler test to determine the remaining antioxidant level. By comparing this to the new oils, we have come to an oxidation resistance index. So if you look at the 9 brands that we have tested, you will see that oxidative resistance index differs a lot. So it's not always related to RPVOT, and the MPC values differ sometimes from the oxidative resistance. So you can have an oil with good oxidative resistance but relatively high MPC, but generally you will see that there's a lot of difference between the formulations. So lower here is better. So we have one clear winner here. Oil number 7 has a good oxidative resistance index and a very low MPC. Okay. So for example, this is an oil that is out of the ordinary, oil 9, because you can see, or oil 2, you can see they have very good oxidative resistance index, but then very high MPC. So if you use this data to make decisions, it makes sense to come up with a ranking. What is important to you? Because different production sites, different environments, different applications, they can have different factors that are more important or that are less important. For example, if you have an application that you expect to have 15 years of oil lasting, and then you will look at expected oil life, oxidation stability, and deposit control. If you want to change your oil every 2 years, then maybe price is more important. If you need a lot of technical support, then this will be more important. So we have come up with a basic ranking of things that we think are important, and all the brands that we have tested, we have ranked according to these qualities. And you will see here that brand 7, 8, and brand 2 are the best performing in this area. So we have taken brand 7 here, and we have further stressed brand number 7. So we have observed excellent oxidation resistance index and excellent deposit control, and inspection of glassware and catalyst coil also did not show any signs. So if you compare that to the poorest performing fluid, you'll see that the oxidation coil is heavily varnished, and the test tube itself was actually heavily varnished, and the MPC patch is almost black, with actually even already deposits here forming. So pretty bad. So the winning candidate here, sample 7, was stressed for an additional 18 weeks, and the MPC value remained in the normal range, and no signs of deposits were found. And this candidate was actually our own formulated infinity fluid, which is formulated using Solvencer technology, which is very stable in terms of deposit control and does not form any deposits throughout the life cycle of the equipment. So that's why this oil gives you long-term deposit control. So just to summarize this section, when we select a lubricant, the first step is to determine the primary failure modes of the application. So you want to know, how does my application fail? How does a turbine fail? How does a compressor fail? So for example, in turbine oil, the main failure modes are related to varnish formation and or antioxidant depletion. So it's typically deposit formation inside your system, which leads to temperature spikes, vibration. In the end, the lubricant will degrade to the point it cannot perform its function, and your system will break down. Antioxidant depletion will lead to the oxidation of your equipment, and as such will lead to breakdown. So this is the most important things that you want to measure in a turbine oil. So you have to develop test data or ensure that the lubricant you're using is tested according to its ability to overcome these failure modes. It makes sense to develop a ranking matrix as we have shown, and you should select the oil that provides the highest value for your application and for the way that you intend to use it. So we have completed now the section of selecting turbine oils. Now I will go a little bit further into oil degradation. So I would like to show and share with you how does oil degrade in turbine oils? What are the primary failure modes that you see? So there's the biggest problem, or one of the biggest problems that we see is actually that's an external ingress of a material into the oil. And one of the most problematic contaminants is always dirt. Dirt going into your oil is not good and will lead to issues. Another very problematic contaminant in turbine oils is water. Water ingress to the oil leads to a lot of problems related to viscosity. It will increase oxidation. It will lead to acid formation, and so on and so on and so on. So water is very problematic. And actually air. Air or oxygen oxidizes. That's where the name comes from. So too much air in your system will prevent the oil from performing its major functions, but it can also lead to rapid oxidation of the oil. So you would look at things, for example, if you have air bubbles in your system, this does not help the lubricant to perform its functions of lubrication in the system. So for turbine oil degradation, there are a few factors, major factors that are taking place. So number one is oxidation, as we explained. That's a very important degradation mode. Another one is thermal degradation, which can happen through static spark discharge. When you have a filter and the oil passes by the filter, there can actually be spark discharge, creating hotspots. Microdieseling, that's pressure-induced degradation, thermal degradation. So I will explain that a little bit further on. And hotspots in your system can lead to accelerated degradation. External contaminants such as gas, solid particles, or water, and other modes of failure and degradation can be drop out of the additives or incompatibility. So we'll look into these a little bit more deeper. So if you look at oxidation, you'll see an oxidation propagation cycle. It's depicted here. You see a free radical being formed. That's the initiation stage, and the free radical starts to react with an oxygen molecule. And then it starts to go into the propagation cycle where it forms a different molecule and it will start to oxidize even further, and you will go into a stage where it will degrade the base oil molecules, and it will go into an auto-oxidation cycle, as it's called. So what you get is actually you have different type of antioxidants. They are responsible for stopping this cycle. So you can have, for example, an antioxidant that takes away the polarity of the molecule. It can do that by either donating or accepting an electron from the free radical, rendering the free radical inert, but it also destroys the antioxidant molecule. So you will deplete antioxidants by doing this. You can also do this by peroxide decomposing or UV absorber. These are a few methods for which you can stop the cycle, but you will lose antioxidants along the way as well. So antioxidants are actually like an apple's skin. So vitamin C is nature's antioxidant. That's why it's important every day to get a nice doses of vitamin C in your body, because it will prevent a lot of degradation processes. So an apple skin is actually highly packed with vitamin C, and it prevents the internals of the apple to react with oxygen outside. So if you remove the apple skin, you will see that the internals of the apple start to degrade. And actually the browning of the color is the vitamin C going to the area that's affected in order to protect it. That's actually why it turns brown. But that's interesting because you will see the oxidation process very quickly happening when you leave an apple out in the open. And that's the basic process that I've just shown. That's the natural way that an apple degrades, is actually through this process. So if you look at a turbine oil, for example, here you see a very extreme example. This does not happen a lot, to be honest, but this is an example that we got from one of our customers, where you see that the oxidation has gone so far that the oil gets extremely thick, and this oil you cannot use in your system anymore. Another form of degradation is spark discharge. So here you can see an example of spark discharge which is done in a test rig, but we also have a lot of examples of real life circumstances. So in this case, you want to look at spark-free filters. Maybe you want to remove some components from the lube oil that are creating this. But the most common solution is to install spark-free filters. So here you see the effect on the main lube oil filters of electrostatic discharge. You see the coking, the carbonization materials getting stuck in the filter. Here also you see the particles on the filtration system. Another mode of degradation is through microdieseling, where there's a collapse of air bubbles through pressure, and you get a microjet, which creates heat, and then you get carbonization of oil, which leads to deposits and varnish formation. So this is how it looks like in the real world when you have excessive microdieseling in a gas compressor. So that's one of the primary modes of failure here. Another common thermal degradation is through hotspots. So you'll get carbonization of a layer of oil that is being subjected to high heat. So you get changes of the molecules, and then it cannot perform its duties anymore. And it will lead to lacquer and carbonaceous deposits forming inside your system. So this is let's stop the video. So that's an extreme example of water in the system, which leads to extreme oxidation, because water can act as a catalyst, and you'll see the viscosity of the fluid shooting up to a point where it actually becomes kind of a goo. And here in this graph, you can see that this is actually done through acid formation. We analyzed this goo, so to speak, and we found out that there were certain acid formation that were causing this. So you need to install, for example, acid scavenging materials to prevent this from happening. So here you see a gas turbine package that provided power to a university campus. Again, sudden fluid degradation due to extreme oxidation, which was catalyzed by water formation and water ingress. So deposits of varnish can also cause elevated varying temperatures or premature filter plugging. So here you can see a filter that has been completely plugged with deposits and cannot perform its duties anymore. And in this case, the system was flushed using our Boost VR product and then charged with new oil. It's also very important to flush systems that have been having these kind of issues, because there will be residual deposits and varnish in your system. So you need to use, you can either before an oil change, you can add the Boost VR, which is our product, which will help to clear the system before an oil change, but you can also flush during your downtime. Deposit characterization revealed that this was caused by oxidized oil. Here you can see in the steam turbine on the tube there is residue which inhibited the equipment from performing, and we have analyzed the deposits and we saw that they were acids and silicas, and so also a result of oxidation leading to deposits here. So there are a lot of gases that are often ingressing into turbines. Now there is this old knowledge that they say inert and hydrocarbon gases have no chemical effect on the oil. This is one of the fights that we are fighting in the market, because this conventional wisdom is actually not correct. Because we have found through our experience that inert and hydrocarbon gases can actually chemically react with the oil, and they actually lead to some of the most severe degradation situations that we have seen in the market. So, for example, if you look at an inert gas such as CO2, it can actually react with water to form a carbonic acid, So oil has, for example, 8 to 12% of air, 21% of which is oxygen. So you can imagine that this is already a reaction product that's by design basically always in your oil. Ammonia can also react with the lubricant. So if ammonia reacts with the lubricant, it will react with anything acidic in the fluid, such as rust and corrosion inhibitors, and it will react with those to make further acids and alcohol, which will degrade your system. And ammonia will also react with oxygen to form NOx, which is a free radical generator. So here we have an example of this in the real world. We actually have a case study by a nuclear power plant in the US, which had 2,700 liters of ISO 32 turbine oil, an MPC value of 16, and ruler phenols were at 75%. But it experienced pump valve sticking, and the unit had to be shut down for 30 hours to investigate the problem. Now, 30 hours for a power plant, as many of you will probably know, can run into extreme costs. So here we have documented that it's about 1 million of cost, $1 million US that was caused by this outage. So a high-profile root cause analysis was performed to determine and to fix the cause. Of course, in this situation, the customer will not spare any expense to get to the bottom of this and prevent this from happening again. So we have removed and analyzed deposits from the valves, as you can see here, and we concentrated and analyzed the degradation byproducts from the oil. And the chemistry of the deposit from the valve matched the deposit in the oil. So we know that the problem that led to valve sticking is actually coming from the oil. That's what we have determined here. The deposits are defined as primary amides, a reaction between carboxylic acids and ammonia. So these are actually byproducts of oil degradation, primary amides, and they react with ammonia to form these kind of deposits. So the chemistry that is actually being formed in the lubricant here is in fact similar to Kevlar, which is used in bulletproof vests. So you really don't want to have this inside your system. So the conclusions and action that we took: ammonia was present in the plant's steam, which was a result of the way it produced. And so you have carboxylic acids plus ammonia related or chemically made deposits that are consisting of amides. So it was not feasible to remove the sources of ammonia from entering the system because, yeah, that's not possible for this plant. So what we have done is we installed a system to remove oil degradation byproducts, which are the carbolic acids. So this part, we have removed this part from the basic chemistry of the oil. So this reaction cannot take place. So the deposits are not formed. So in addition to MPC, the plant is also monitoring with FTIR to measure the acidic content and keep check of amide production. So here we have stopped the problem at its core. And of course, this customer was very happy with this. So here you can see some example of other deposits that you see very often in the market. So here you see that sort of a bad top ring that forms in the oil tank. And you can see from the different layers that it has been there for quite a while. And you can also see that it has different intensities, meaning that you have different levels of severity throughout the life cycle of the oil. So at some point, these oils were very highly varnish, high in varnish potential, and at some point less, probably due to an oil change. But throughout all these formation of these layers, this oil has been causing varnish in the system. You can see here how it looks like when it's on the piping. So you can imagine that this can lead to issues. Also, this kind of deposits are like lacquer, so it's impossible to wipe. So you need to use some heavy chemicals in order to remove that, which is not advised because even residual chemicals can go into your oil and can prevent the oil from performing its duty. It's never advised to use detergents in cleaning of oil tanks. So here you see a worker trying to clean the varnish that is in the system. In this case, the deposit was determined to be a polyacrylate, which is used as a foam emission additive. So in this case, it's actually an additive in the formulation that actually came out of solution, started oxidizing, and formed this very hard deposit. So another use of polyacrylate absorbent material is it is actually the absorbent material, sorry, in baby diapers. So chemistry is very interesting in this. So also incompatibility is a big issue that we see in the market. People tend to mix oils, top up oils, and so on, which has been the school of thought traditionally, but because nowadays we have more purity in base oil, more solvency challenges, more advanced chemistry, so incompatibility of fluids becomes more of an issue. So you see here an example of these white threads that are typical of chemistry in an oil coming out of solution because the oils are incompatible with each other. And here you can see it in the system as well. So new formulations have various base stocks and additive components, as we have discussed earlier, and they are not always compatible with each other. So, for example, most group 5 base stocks are not compatible with mineral oil. Old foam inhibitors may not be compatible with newer type foam inhibitors. They have different chemistries, so they cannot always mix. Different kind of rust inhibitors can also be incompatible. So overall, mixing different chemistries is never advised. Even if you test 2 new oils together and they might be compatible, if you do the same with used oils, you might run into compatibility issues with the same oils, because when an oil is in operation, when it's in service, it chemically changes. So there are chemistry processes that are taking place inside the oil. So they are different in composition compared to a new oil. So mixing new oils to check if your oil that is already in service is compatible with another oil will not work. So that's why we say it's critical to test. Never assume compatibility. So ASTM D7155 is the standard for assessing compatibility of mixing turbine oils. And our solutions will always be tested for compatibility. But this is, for example, a compatibility problem that we have encountered in the compressor. 6 months after installing, the bearing temperature started to go up, and oil analysis results indicated no problem. But after assessment, we can see deposits visible on the bearings and the shaft, which was in appearance very atypical of varnish. You can already see it's very light in color and it looks softer, looks a little bit like rust scattered on the metal, but that's not what it is. It's very atypical. So when we magnified it after solvent extraction, and you will see that the varnish deposits were insoluble, and we performed an analysis to determine what they are. So the majority of the deposits were sodium and sulfur. Now sodium is used as a dispersant in oils. Sulfur is an EP additive. So in this case, the sodium could come from the additive chemistry, could also come from external environments, but the sulfur is definitely from the chemistry of the oil. So this typical oil formation did not contain sodium, but the compressor was not flushed during the missioning. So there was some preservative oil remaining in the system. So that's a big example of incompatibility of two different oils. So the residual rust preservative oxidized and formed deposits, in this case, on the hottest areas of the equipment, which is always the area that leads to problems. So that's why it's always severe, because the problem will not occur somewhere where it's inert. It will always occur at a critical point where it will actually become a problem. So a little bit of a summary about oil degradation. So it's very important to realize that varnish is just a word, but definitely not all varnish is the same. It makes sense to do a root cause analysis to figure out what is exactly the varnish that I'm experiencing. How does it originate? Where does it come from? There are multiple mechanisms that may be the cause for oil failure and for the formation of deposit. and getting a sample of the deposit can help identify the cause and point to a solution. So we see a lot of operators, they take pictures, but they don't take samples. And this is actually a missed opportunity, because if you keep some of the deposits and you let it be analyzed by us or by a lab, an independent lab, then actually you can find out in many cases what is the cause of these deposits. So one of the most important aspects of maintaining a turbine oil is actually oil condition monitoring. So that neatly brings us to the next topic. I'll check it. I think there are a few questions, but I will try to keep it for the until the end, because I'm a little bit behind on time. So we'll treat some of the questions in the end. So I'll continue for now with oil condition monitoring. So oil condition monitoring starts with sampling. This is always the first step. So the objective for sampling is that you maximize the data intensity. You want to get as much quality data as you can. You want to minimize the data disturbance, and you want to have a proper frequency. So you can also sample too much, which can be detrimental, or more often it's actually too little. So you want to determine a proper frequency for your application. So some considerations for sampling will be to sample from a proper location, use the correct sample hardware, the correct sample bottle, and put in place a correct sample procedure. Because with sampling, it's very simple. If you put garbage in, you get garbage out. So in order to get usable data,
Mati zoom-nya ya?
one slide before this one. So I hope you can see my screen again and can hear me okay now. So as I was explaining, conventional analysis devices are elemental by ICP, viscosity, STIR, or titration. But at FluidTech, we have developed an MPC test called membrane patch colorimetry which is categorized under ASTM D7843. So here's a short video of this test and how it works. And you will see that it generates a patch by going to a patch, and you will run a tree parameter to determine what is the delta, which is then categorized as MPC value. Here you can see an example of the patch. So from here you can see an example of different MPC values. So you see the one on the top corner has a very low delta, so that's almost no varnish potential, which is similar to what a new oil would be. Anything above 25, we typically say you have to start being careful. Anything above 40 is typically categorized as critical. So keep that in mind when you run MPC tests. This is an extreme example on the bottom right, where you have an MPC of 110, where your oil is basically destroyed already. So you can have different colors when you do an MPC test, because these are related to the chemistry of the oil. And remember, the color of an oil is not always related to the varnish potential, because very often people think when my oil is dark, it will be varnish and I have to throw it away. But that's not always the case. Color change of an oil can be due to various circumstances. Some can be detrimental, some can be very harmless. So oil color is not representative of oil performance. Another very important test to consider is linear street voltammetry, or RULER. RULER stands for Remaining Useful Life Evaluation Routine, which is categorized under ASTM D6971. And it uses our proprietary RULER equipment invented by FLUITEC. And it actually measures the amount of antioxidants that is left in the oil. So you see here on the screen the RULER graph that is here being generated by the technician. And this is a reference test. So you get a graph that is the new oil. In this case, the blue line is the new oil. And then you see the other test. This is a test after TOPP is done 1 week, then a test after 2 weeks, 3 weeks, 4 weeks, and so on and so on. It becomes more interesting if you correlate your RULER tests with an MPC test, because you can actually determine different kinds of failure modes and varnish chemistries that are taking place. So if you do an MPC test, combine it with a RULER. If you want to do a RULER test, combine it with an MPC, because you might be able to make some interesting conclusions following this test. So if you look at the remaining useful life overall of an oil, you want to correlate MPC and RULER. So we say for RULER test, the phenols typically will deplete first, and then the condemning limit for the amine antioxidant level is about 25%. That's when you really want to think about changing your oil or adding additives into your oil to increase the antioxidants again. MPC testing, anything between 15 and 30 is monitor, between 30 and 40 is abnormal, above 40 will be critical. So if you correlate these, you can determine the life of the oil, whether that's normal, abnormal, or when you're at a critical stage of your oil. So if you look at an oil analysis, this is a typical oil analysis test slate. So how do you want to interpret this kind of analysis? So for example, it starts with sampling. So oil analysis tests that are influenced by sampling techniques can be the air release properties, the contamination, because if your sample bottle is contaminated, you will see this back in your oil analysis. All these wear metals can come from outside if the sample technique is not proper. So very important to use proper sampling technique. So if you look at interpreting oil analysis reports, it usually starts with viscosity. There's this saying in the lubricant world, there are 3 main important aspects of an oil, which are viscosity, viscosity, and viscosity. So everything always starts with viscosity. You check that, then you check if there is any wear metals inside the oil, then you look for contamination, then you look at varnish potential and oxidative health, and you combine this with other fluid properties to make a holistic analysis. So what you want to do if you want to proper oil analysis interpretation, you need to look at data points. So you need to have a record of sampling, and you trend the data to see where it's going, so you can make preventive analysis. Find correlation between results and take action. You want to use this data to come out with a preventive or reactive monitoring. So make sure, number one, that the viscosity is correct. As a matter of fact, 99% of the time, we'll see that viscosity is correct. It's very rare that viscosity is affected by degradation. And if it is, then it's already a very severe degradation. But it's the first thing you want to check. Then you want to make sure that there are no wear metals suggesting extensive wear. Also here, you will see most of the time, this is not the case, because by the time the system will generate wear metals, there will already be a severe problem. So typically, this is already indicated before that. But you absolutely need to check for the wear metals. So then you determine if the oil is contaminated. For example, very common contamination can be water ingress. So you look at the amount of water that's in the oil, and there is the isoparticle count measurement, which will generate a number where you can see if there's which is related to the oil cleanliness in terms of the particles that are inside. External contamination can come from several elementals. And you look at additive levels, which are typically found in lubricants. So, for example, the increased water ppms or isoparticle count, you can have a coolant leak, for example. Maybe there's a filter change required, maybe your filters are saturated, or it can be due to a sampling error. If you have contamination of these elementals, you could have, for example, as I mentioned earlier, it's not advised to use detergent when you clean the oil tank, because this can end up as a contamination in your lubricant. It can have a cross contamination with another lubricant. Maybe you have topped up the oil with a non-turbine oil formulation, leading to contamination, and so on and so on. So phosphorus, for example, is an EP additive and an anti-wear additive that's used in some turbine oil formulation, so don't be disturbed if you see this. So what is varnish potential and oxidative health of the oil? So these are typically measured by a combination of RPVOT, which is designated in minutes, the ruler test, which we've shown earlier, which measures primary and secondary antioxidants, MPC for varnish potential, and ultracentrifuge test as well. These give you a good idea. And we have to look at, for turbine oils, you really want to consider these tests because they are extremely important. As we explained earlier, those are the two primary failure points of turbine oils. That's varnish formation and antioxidant depletion. So you really want to keep an eye on the varnish potential of your oil and the antioxidant level. The condemning limit is when an RPVOT is lower than 25% of a new oil, or when the A- drop to 25% of the new oil. And for the MPC, an action should be taken when MPC is higher than 30. You can also combine this with ultracentrifuge. Some labs will do that to give you an even more thorough picture. And action should be taken there when it's greater than 2, equal or greater than 2. For MPC, trending is also very important, because if you, maybe your MPC is still below 30, but if it trends from 5 to 25 within 3 months, you would also want to take action, because that might indicate a problem in your oil as well. So trending data is very important. So other fluid properties can be acid, air release, foam emulsibility. So foaming will be influenced, for example, by contamination as well, water ingress to the oil. You will see this in foaming and demulsibility. Acid number will be only affected at a very late stage of degradation of the oil. Typically, we will see that for hydrolytic oils, which are, for example, phosphate esters, they attract water. And when they attract water, you will see that they start to become acidic after a while. So that's a typical application where you want to keep an eye on the acid number, because they can indicate a problem with the hydrolytic properties of the oil. So if acid number increases, it means your oil is already extremely degraded, and only very hot running turbines will typically see acid number increase. Air release and emulsibility are influenced by base oil degradation and contamination. So the emulsibility is important because in oil's ability to keep water or other contaminants outside of the oil. So a little bit about some practical case studies and the importance of trending and correlation in this case. So here you will see that if you look at the trending of the RPVOT, and you correlate this with the ruler and MPC content, you will see that as the amines and phenols go down, you will see the RPVOT going down, and you will see the MPC creeping up. So if you look at this in a graph to make the correlation, you will see here the RPVOT is the blue line. It will go down alongside with the ruler amines and the ruler phenols, which have depleted very quickly here. So you can see the correlation between RPVOT, and you will see the MPC going up. So all these tests are related, and you can make correlation that you need to take action here in order to correct the oil. So possible action steps in this case to install varnish mitigation systems and to increase the antioxidants or re-additize the oil to bring the RPVOT back up to an acceptable level, so you do not have to change the oil. But of course, changing the oil is also an option in this case. Here you see an interesting case where you have a good oil analysis trending taking place. So suddenly there's a lot of problems with foaming in the oil. You see rapid antioxidant depletion, the MPC shoots up, and the oil becomes problematic very quickly. Now here you can see from the elemental spectroscopy that there is zinc ingress in the oil. So in this case, and calcium, which is not supposed to be in the turbine oil. So in this case, there was hydraulic oil that was mistakenly dosed into the turbine system. So we can derive that from this oil analysis. So in this case, to answer these questions, the type of contaminants is hydraulic fluid. Parameters that are critical in this case would be foaming, the emulsibility, MPC values, and possible action steps that are next. In this case, it is to change the oil because there has been contamination. So you really want to flush the system and change the oil in this case. As you can see here, foaming is critical, demulsibility is critical, and then you see here the elementals that are causing it, and the MPC value going up as well. So the summary here for oil condition monitoring, you want to look at the two most important factors: antioxidant health and varnish potential. Please ensure that your oil analysis packages include these tests. Oil condition monitoring in general is pointless unless you have an action program as well, because very often we see that oil reports go into the drawer and nobody really does anything with it, but you need to have an action plan in place as well in order to mitigate any problems. So final topic that we have for today is to talk a little bit about our solutions, FluidTech solutions that are in the market to mitigate varnish. So we have two basic solutions for varnish in the market, which is fluid enhancement, or known as Solvencer, or a filtration system known as ESP. Solvencer is a solubility enhancer. It's a unique product. It permanently increases the deposit control of the oil. ESP is a unique filtration system. We have over 1,000 units in the field, and we have a unique filter media which has no competing technology right now, and it can severely extend the life cycle of the oil. So if you look at fluid enhancement Solvencer family, Based on this solvencer technology, we have several products. The all-rounder here is Decon, the one on the top. And Boost AO is re-additizing the antioxidants. Boost AW is for oils that have anti-wear additive. And Infinity Turbine Oil is our own turbine oil blended with solvencer technology, which was shown in the TOPP test earlier. Boost VR Plus is a product that is added to the oil as a flush before changing the oil. So Decon is the most all-round product. Decon is the most all-round product which can be used in both reactive or proactive way. So it can be used as a correcting method. For example, if you see varying temperature shooting up and you want to correct this, you can use Decon into your fluid, but you can also add it as a preventive measure, so as a proactive deposit control system. So you can do it before there is any problem with your oil or with your system. You do not have any reason for it, but you want to prevent problems from occurring, so you add Decon into your system. This will be a long-term solution because Decon does not degrade, does not form any varnish or deposit inside your oil, so you can use it throughout the life cycle of the oil without any issues. Infinity Turbine Oil is the only turbine oil in the market currently that comes with a 10-year deposit control guarantee and is designed for additive refortification by our Boost AO. So this will provide a very long service life, and it's a unique oil in the market. So when we talk about varnish a little bit and to understand our products, specifically the filtration, you need to understand that varnish is soluble. This is why it's so challenging to remove varnish from an oil, because it goes into solution. It's like sugar dissolving in your tea. You cannot take the sugar out anymore, but it can still be harmful to your system. So that's what this picture here, this video shows. Varnish will completely solubilize into the oil, and it cannot be removed by by mechanical filtration. So you need to have another solution to take care of your varnish. So there are various technologies that are available in the market. You can have depth media filters, electrostatic oil change, oil cleaners, charge agglomeration, or a chemical filtration system. So all these technologies can remove varnish under the right conditions. So we'll talk a little bit about the pros and cons of these systems. So if you have depth media filtration, the pros of this are it's simple and economical to operate. It has high dirt holding capacity, and it absorbs soft contaminants and also can absorb moisture. The cons of this kind of system is that it only works in low temperature operating condition, and it cannot remove varnish that is solubilized. It can only remove varnish that's in suspension, meaning you have to reduce the temperature of the oil before you can take out the varnish. So this makes it only suitable as an offline system and not an online system for removing varnish. Electrostatic oil cleaning has some pros, but it's also only able to remove varnish that is in suspension and not in solution. So also is only suitable as an offline system, and it can be difficult to operate. So our solution of choice is to use ESP, or chemical filtration. So the biggest the biggest upside of this is that it removes soft contaminants that are both in suspension and in solution. So it basically is able to take the sugar out of your tea, so to speak. It is able to remove the varnish from the oil while this is in solution. It has a wide range of temperature effectiveness, so it can be used as an online system. You just plug it into your oil tank, you install it there, and it will work throughout its life cycle. Just need to take care of changing the filters in time when they are saturated, and it will keep the base oil clean and pure. So if you remember, that's the main reason why we are in business, because we want to keep the base oil clean and pure so that it can provide its main functions. So it's also relatively simple in design and easy to operate. And the downside of ESP is that it does not remove inorganic contaminants, so it does not have any impact on dirt, contamination, and metals. So it works by when a new oil starts to degrade, when it's in service by thermal or mechanical stresses, it creates soft soluble contaminants into the oil, which can settle in the form of varnish, as we have showed earlier. The ESP takes out these soft soluble contaminants and restores the oil back to new and keeps the base oil clean and pure. And the new oil, the clean oil, sorry, goes back into your system. And when oil is clean, it is able to absorb varnish again. So by using an ESP system, it will actually clean up your whole system, because varnish that is already present in your system will be reabsorbed into the oil. So the process, the way it works is by resin. So we have resin media which absorbs soft soluble contaminants and keeps it onto the resin, and this will render the varnish inert. So it will increase also the antioxidant life and the general life cycle of the oil. So here you can see an example of the media. You have fresh media in the picture on the left. You can see this here, the resin is not saturated with varnish. And on the right side, you have an example of spent media where it has absorbed all the chemistry, the varnish potential of the oil, and as such has kept the oil clean and pure. But this is also the reason why you would have to change filters every 6 months in this system to be able to continuously remove the varnish from your system. So this is the ESP resin in action. You can see here the resin media absorbing the soft soluble contaminants from the oil. So that's ESP, which is a very effective and efficient system to keep the oil clean and pure. We also have a chemical solution under decon, which is simple and so typically decon treat rate is between 3 and 10%, and it can be poured directly into the oil reservoir during system operation. And it has a wide range of applications, so it is also compatible with, for example, hydraulic oils and any oil that's formulated with an API group 1 to group 4 base stock. And decon actually works as a solubility enhancer. It dissolves the varnish back into the oil, and as such takes it away from your equipment and protects your equipment from breakdowns. So you can see the effect of decon is immediate, because before solvencer we have here some high MPC values, and after using decon with solvencer technology, you immediately see the MPC values going down and the patch becoming more clear. So it also has outstanding long-term performance. So this is why we can claim that it is risk-free, because in the TOPP test, it keeps the MPC even after 18 weeks under 10. So normally we test TOPP for 6 weeks, but we have extended the test threefold, and there has been no problem with varnish potential in this oil after it's been treated with decon. Also in the real world, we have a lot of experience. This is just one example, but you can see an N2 feed compressor with high varnish potential shooting up to 60 after treating it with solvencer. And we can see that the oil has very low varnish potential. This is over a span of 3 years. And we have many of such cases available also for turbine oils with high bearing temperatures. We can use decon to remove the varnish from your bearings and to reduce the bearing temperature again. So you might think, should I use decon or ESP? Well, actually, the beauty of this is that you can actually use both. They work in perfect tandem. If you look at the oxidation process, you will see that ESP will take out the radicals after they start reacting with other chemistry in the oil. So it will actually increase the life cycle of your antioxidants, because antioxidants do not need to be used as much to stop the propagation cycle, if you remember earlier on in the presentation. So ESP actually prolongs the life cycle of antioxidants. Solvencer actually prevents the formation of varnish and gives you extended deposit control. So using an ESP and solvencer will be the most ideal solution to prevent varnish formation and to extend the life cycle of your oil, and all related to keeping your oils clean and pure and providing a risk-free solution. So you can see this also when you test here a turbine oil with solvencer. You can see the MPC going down, but the antioxidants are not affected. If you test the turbine oil with solvencer and ESP, you'll see the NPC is even lower, but the antioxidants are also kept in good health, and they are not depleted as fast as without ESP. So ESP actually helps here to extend the life cycle of the oil. You can see it in your RPVOT values here, where we have a 91% improvement due to the ESP system, where we have 678 minutes of RPVOT. So these two work pretty good in tandem. So I would just like to summarize a little bit about our products for varnish mitigation. So it all starts with science and analyzing and education for us. So we want to share also knowledge with our partners and with the market, such as we do today. Then it's very important to do condition monitoring. So technologies here for rule of view and NPC to monitor the most important aspects: antioxidant health and varnish potential of turbine and compressor oils. Contamination control can be done to our unique technologies with unique filter resins, which is the predominant one is called Vita ESP. We also have stealth EHC for phosphate ester fluids to blanket and prevent water ingress, spark free to prevent electrostatic discharge, and Endure 9s as well. Fluid enhancements such as Boost VR, Boost AO, Boost AW, or Decon, and Infinity turbine oils formulated with our solvencer that are engineered to last the life of the equipment. So that summarizes our products and brings me to the end of my presentation today. It's a little bit over time, but it's quite a lot of information that I want to share with you. I hope it was not too fast today, and I hope you have enjoyed this and it was useful for you. So thank you very much, Adi, for allowing us to present. Thank you to all the attendees for attending this webinar, and we hope to be able to help you to help monitor your oil and keeping your base oil clean and pure. We look forward to engaging more with the Indonesian market. So thank you very much.
And maybe we can have some times to answer one or two questions.
Yes,
Can?
sure.
Yeah. So there is so many questions that we receive, but I choose one or two questions for this moment, and another question we can answer it separately, or privately. Okay. Second question regarding the governor valve using EH oil or phosphate oil and have a water content 5,000 ppm. So this customer already know that the root cause is regarding the cooler system leak, cooler system leak, sorry. And please inform what other problem you'll be facing if the water content are high in a phosphate ester, and what is the tolerance water content on phosphate ester oil here? Okay.
So 5,000 ppm is quite high. So in that case, you will run into foaming issues and demulsibility issues. But what is most important is that the water content will accelerate the oxidation process. So you will run into very quick oxidation and acid formation inside your oil. And you will see the TAN number going up. And once that happens, you will have acids that will start to attack the metals of your equipment. And that will lead to corrosion of the metals and eventually to a breakdown. So it's very important for phosphate ester fluids to manage the water content and to prevent water from ingressing into the oil, which can be done. We have a system for that called Stealth EHC, which is specifically for EHC systems, which is a dry blanketing. It puts a nitrogen blanket on top of the oil, preventing external water from ingressing into the oil as a contaminant. Another system that we have is the Endure 9, which can be installed on our Vita ESP system, which is acid scavenging. So it can remove all the degradation byproducts from the phosphate ester fluid, and it will prevent the metals from degrading. So if you install these two together, you are relatively safe, and you will manage the downsides of a phosphate ester fluids very well.
Okay, thank you, Lars, for your detail. And you mentioned about your technology of oil or solvencer. So the question is, what are the advantage of your oil or product oil compared to others, and what standard you using as a reference for turbine related oil product?
Okay, so for us related to other products, if you look at filtration, for example, because there's some different ways of looking. If you look at our filtration systems, the ESPs, our resin is unique there. So it's not like mechanical filters which do not remove varnish. So we have actually a resin that's tailored to removing varnish from the oil. And we also have tailored the composition of this resin to different oils. So what we will do is we will ask you what kind of oil are you using. We will ask you to share your oil analysis reports with us. And based on that, we tailor a resin specific to your equipment or your oil type and application. So that's unique because other companies do not do this. In terms of the solvencer technology, as far as I know, there is no such technology available in the market, and we are the pioneers in this area. And for our infinity turbine oils, for example, this leads to extensive deposit control, and we can give a 10-year deposit control guarantee. Of course, it comes with certain conditions, and you need to use the oil properly, as with anything in the world that comes with a warranty. But this is also unique. Other companies do not give this kind of warranty on the oil, and that's how confident we are in solvencer. We have also obtained recommendations or even approvals from OEMs such as Siemens, which have put FluidTech in their service bulletins, in their manuals, which recommend ESP systems. Solar Turbines has a cooperation with FluidTech. We are managing over 60 Solar Turbine accounts together with them to generate more data. So we have the backing of the OEMs, of the turbine manufacturers as well.
Okay, thanks, Lars. So I think we have a great webinar by today, and thank you for your time and the sharing. And then hope we can have a next webinar and sharing in the future.
Yeah. Yes, thank you very much, Adi. There's much more we could talk about. For example, on phosphate esters, we could do a separate topic on that. So look forward to doing more of these in the future.
Yes. Okay.
Thank you.
Thank you. Terima kasih Bapak-Bapak, Ibu-Ibu yang telah mengikuti webinar pada siang hari ini. Jadi secara kesimpulan, turbin merupakan salah satu equipment yang kritikal di dunia industri, yang mana salah satu bagian pentingnya itu terkait dengan oil. Dan oil condition monitoring merupakan program konmon yang penting dilakukan untuk mengetahui kondisi oil dan equipment itu sendiri. Terima kasih Bapak-Bapak, mohon maaf apabila ada kekurangan pada sesi hari ini, dan saya informasikan juga untuk link rekaman dan e-sertifikat akan dikirimkan melalui email sebelum tanggal 15 Februari 2021. Okay, Lars, thank you for this session. Yes, yeah.
Terima kasih. Thank you. Bye-bye.